Swayam Prabha. Digital India. Educated India.
Okay. Now, we discuss about the room acoustics. Okay. Room acoustics means that if suppose if I create a sound in an enclosure, this is the enclosure. So, room acoustics means it can be a auditorium, it can be a classroom, it can be a theatre room, it can be my drawing room, whatever is the room acoustics. Okay. So, what is room acoustics? Now, I said that the sound will be reflected from different surface. So, suppose I create a sound in here. So, that will be reflected back from different surface, from ceiling, from ground, from wall, or from door, from window. Always it will be reflected. Some portion will be passed back, some portion will be absorbed by the media, by the wall. So, that kind of phenomena will be happen. That is called room acoustics. So, how do you study the room acoustics? What are the parameters we have to define for room acoustics? Now, when you design the acoustics of an auditorium, what are the properties we should look for? All has to be discussed in room acoustics. So, let us start with that multiple reflection. So, I already discussed this one. So, room parameter. What are the basic parameters available for a room? Height, width, length and shape of the room. So, height, there is a height, length, I can say that shape of the room, it may be a circular, so there may be a radius, so it may be a hexagonal, that kind of things will be there. So, height, length, width and shape is there. How the surface reflect the sound is determined by the wall material and its preparation. Okay. This quantity is described by the absorption coefficient. Now, we discuss the absorption coefficient. So, what is absorption coefficient? Suppose I have a wall. Okay. Let us a sound is incident on the wall. So, it will be reflected, some portion will be reflected, some portion will be transmitted. Along with that transmitted, there will be some absorption. So, the unless it is suppose that incident is P and some portion is reflected. So, rest portion is absorbed by this wall, this wall is absorbed that sound. So, that is sound absorption. Okay. So, in that case, so if a surface has an absorption coefficient A, that means if a P is incident on that surface, P into A will be absorbed by the surface. So, the reflected is 1 minus A. Okay. So, A is called absorption coefficient. So, if the I say the unity power, unit pressure 1 is the unit pressure is incident on that. So, the A unit into A will be absorbed by the surface and 1 minus A will be reflected by the surface. Now, in a room, if I create a sound, so it is A will be absorbed and 1 minus A will be reflected. Similarly, it will fall on this wall, then this reflection will fall on this wall, then will create a reflection. So, all reflection it create a sound pressure level, or you can say if I switch on the microphone, switch on the loudspeaker in this room, for some time it is required to reach the steady state level of that room sound field. Then if it is a reverberant field or it is a semi reverberant field, since there is a absorption, it is a semi reverberant field. So, sound pressure level is reached in a steady state. Okay. So, if the absorption coefficient is A, then the absorptivity of the surface is defined by area of the surface, let us S multiply by the A, and which is called capital A. A is equal to, surface area multiplied by absorption coefficient. A is measured in term of called Shevin. A is measured in term of Shevin. I told you that suppose I have a room. Okay, this area of this surface is S1, area of this surface is S2, area of this surface is different S3 and this is S4 and absorption coefficient is A1, A2, A3, A4. So, total absorptivity of the whole 4 surface is nothing but A is equal to S1 A1 plus S2 A2 plus S3 A3 plus S4 A4. Okay. So, there may be a window, absorption coefficient is different. There may be a door, absorption coefficient. So, area of the door multiplied by the absorption coefficient and total 7 is A is nothing but a surface area multiplied by the absorption coefficient and all sum is called total 7. Okay. Now, if I say what is average absorptivity? So, average absorptivity A is nothing but A by total surface area. So, what is the total surface area? S is nothing but S1 plus S2 plus S3 plus S4 divided by A by S. Let us do that mathematics, then you understand what is this is that. A room 3 meter tall with floor and ceiling is 8 meter into 5 meter. Okay. So, I can say I have a room, okay. We have a room 8 by 5, that means this is length is 8, 5 is width and 3 meter is the height is 3 meter. So, I said that ceiling has absorptivity different, floor has and wall has. Now, what is A? So, A is nothing but a this surface multiplied by the wall, this is 4 wall is there. So, I can calculate the area of the 4 wall multiply the wall absorption coefficient plus area of the ceiling multiply the ceiling absorption coefficient, area of the floor multiply the floor absorption coefficient. Okay. Then I get A. Now, what is average absorptivity? A is nothing but a capital A by total surface area. Okay. But this A absorptivity is depends on frequency. If you see in practical, I show you also that once you buy a material or acoustics treated material, the absorption coefficient is written with a frequency range. But for this frequency it is this. So, up to this range it works, after that frequency it may not work, absorptivity will totally change. So, absorption coefficient is frequency dependent. Now, I come how the sound field is growth of the sound field. Suppose I have a room, multiple reflection is come. So, number of reflection, there is a lot of reflection, and if I say the number of reflection is statistically significant such that at any point of time average number, any point of that room, the average number of reflection is same. Okay. So, statistical mode assume that the entire room is uniformly filled with sound energy. The sound has repeated oscillation with wall, losing energy with each collision as determined by A. The room volume is V determined by A, and the number of reflection statistically so large that at any point in the room, the number of average number of reflection will be same. Okay. So, this is called statistical model of, then I can apply the statistical model of reverberation time. Forget about the mean free path and this n, I will come later on. So, how the sound is growth? Simple model for growth of sound in a room. How the sound, let us derive the mathematics, how the sound is growth in that room. Okay. Now, let us consider, if you see, let us consider a area which is called del S. Okay. So, when a source of sound is started in live room, reflection at the wall produces sound energy distribution that become more and more uniform with increasing time. So, what I do? I play a loudspeaker and wait for some time, let sound settle down, means it reach the steady state. Ultimately, except close to the source or the absorbing surface, the energy distribution may be assumed to be completely diffuse, that means equal. Number of reflection at any point is equal. Now, consider there is a wall in any surface, there is a surface area which is del S. I put a source whose energy density is psi, and there is a volume of sound dV. That means what? Suppose in this room, I consider a small area del S in the wall, and I say a cube of sound volume dV is strike on that surface with the angle theta. Okay. Then it will be reflected. Okay. So, acoustic energy in dV in this volume is nothing but a energy density psi multiply by the dV, psi multiply by the dV, that energy density. So, volume multiplies the energy density is total energy. So, within this volume the total acoustics energy is psi dV, and that strike the surface of del S with the angle of theta. The amount of energy strikes in del S is nothing but a total energy divided by 4 pi r square is the total hemisphere surface multiplied by the del S cos theta. Have you understand this? I said I have a small surface del S, a volume of energy, you can say the packet of energy strike on the surface with the angle of theta. Since the acoustics energy is flowing through a spherical in nature, so what is the total energy when it strike in the wall is nothing but a 4 pi r square. Okay. So, what is the projection of the surface within that sphere is nothing but a del S cos theta. So, I can say psi del V divided by 4 pi r square is the unit area multiplied by the effective area is the energy which should be strike in that wall. Okay. Now, consider this picture. So, let del B is a part of a hemispheric shell of thickness del r and radial distance r centered on S. So, what I said, this volume is a part of a hemispheric shell whose thickness is del r and the radial distance is r from S. The acoustics energy del E contribute to del S by this entire shell is obtained by assuming that energy arrived from any direction with equal probability. That means, if I say this ball is strike, next one ball is come from the lower direction is strike. So, in different direction, different sound packet or energy packet, sound energy packet is strike on the del surface. That is nothing but a hemispheric shell is arriving at del S. Okay. So, how do I get the total? So, how do you get the total energy del E contributing to del S? Because it is not, once I on the sound system, it is not that sound will go for a angle theta only on that del S. There will be different theta angle is possible on different direction it is coming. So, different theta is possible. So, I can say as like a hemispheric shell is strike on the del S surface. So, how much total energy due to the all kind of reflection is contribute to the del S. How do we get it? Now, del E, del V, what is the del V of the hemispheric shell? It is nothing but a 2 pi r del V is 2 pi r sin theta r del r into d theta. 2 pi r, this is the simple arithmetic, simple geometry. 2 pi r, what is 2 pi r? Is the circumference multiply by the sin theta r dr into d theta. Okay. Now, what is total energy? Del E? Del E is nothing but a, what is del E? Del E is nothing but a volume packet. What is the packet? Packet is sigma dV by 2 pi r square del S cos theta. So, it is the amount of energy strike on del S, which is sigma dV divided by 4 pi r square del S cos theta, okay, for single packet. Now, it is entire hemisphere is striking, whose volume is this one, then total energy is nothing but a integrating from 0 to pi by 2 on this. So, del V will be replaced sigma by 4 pi r square into del V, which is 2 pi r sin theta r dr or del r del r into d theta into del S cos theta. So, 2 pi cancel, pi cancel, r and this r is create r square cancel, and so 2 by 2. So, it is nothing but a sigma into del S, so sorry, psi into del S, psi into del S into del r 0 to pi by 2 sin theta cos theta d theta and divided by 2. Now, if I do this integration, what I will get? I will get psi del S del r divided by 4, if I do this integration. Okay. So, the energy arrived during the time interval. So, what I get? I get del E energy contributing on the surface del S, total energy by the all reflection is nothing but a psi del S del r divided by 4. Okay. Now, what is del r? What is del r? Del r is the distance. So, I can know that del t time, how much time is taken to cross the del r? Nothing but a del r by c, velocity of the sound. So, I can say del r is nothing but a c into del t. So, I can say it is nothing but a sigma del S into del t into c, or I can say del E by del t is nothing but a sigma del S into c divided by 4, sigma c del S into divided by 4. So, del E by del t. So, rate of energy fall on unit area. If I say the rate of energy fall on surface area is del S. So, rate of energy del E by del t, which is fall on that surface. So, in unit area del S will be not there. So, the amount of energy on unit area is nothing but a sigma c psi c divided by 4. Okay. Now, psi c divided by 4 is the rate of energy fall on the unit area of that surface. Okay. So, it is the rate of energy fall on the unit area of surface. So, I know that what is the rate of energy incided on the surface, unit area of the surface, that I know. So, assume that one part of that incident energy is absorbed by the surface and one part will be reflected back. Okay. So, energy arriving and departing, that incident and reflected are individual ray path, the ray have random in phase. I know that it is random. So, energy density at the point is the sum of the energy density of the each ray. So, I say what I said that suppose I consider this area, this del S, this is the area in the wall, and I said from different direction the packets of sound energy is come, and I know the rate of incident energy per unit area on that surface. Okay. Now, same things I can consider, let us different pressure energy, pressure ray, consider as a ray. So, different, so I can say this is the del S. So, different pressure ray are incident on that surface and it is reflected back. Okay. So, what is the total reflected energy? Energy density at each point the sum of the energy. So, if each reflected energy is PR, let us not energy, let us pressure, reflected pressure is PR. So, energy is nothing but a sum of each energy for each of the ray, each of the reflected sound. So, sigma I, psi I. So, it is nothing but a PR square divided by rho 0 C. What is PR? Reflected sound, let us total reflected sound pressure is PR, then it is nothing but a PR square by rho C. Okay. Now, total reflected sound pressure is nothing but a PR square by rho 0 C. PR is the reflected sound pressure, and the energy incident on the rate of energy incident on the unit area of the surface is A, it is sigma C by 4, sigma C by 4. Let us, the absorptivity of the surface is A. So, how much energy will be absorbed by the surface, unit area of that surface, the multiply by the absorptivity. So, it is nothing but A psi C divided by 4, total sound which is absorbed by the wall, total sound incident, energy incident sigma C by 4, and this amount is absorbed. Okay. So, energy being absorbed by the wall, unit area of the wall is A psi C divided by 4. Okay. Understand or not? So, now if I say this much energy is absorbed. Okay. So, rest of the energy will be reflected back, rest of the energy will be reflected back. So, that reflected back energy will develop the sound field in this room, it added with the direct sound and develop the sound field. That means, I switch on the microphone, my loudspeaker for some time and then switch off. Then what will happen? Different direction, multiple reflection will come and that develop the sound pressure level. Okay. Now, so energy which is absorbed plus the rate at which the energy is developed in this room is equal to the total energy. So, I can say the rate of absorption of the energy by the surface plus the rate at which the increase the volume B must be equal to the input power. So, I say this volume is V, room volume is V del psi by del T plus A C psi divided by 4 is equal to total energy. Understand or not? Total energy. So, this is the total energy equation. So, in a enclosure room, if I switch on a loudspeaker, multiple reflection will develop and the equation of the sound total energy is this. Input total energy, input power. Now, if sound source is started at t equal to 0, I can get a solution. The t equal to 0, no energy, before t equal to no energy is there, it starts from the 0. So, I can get the solution with the initial condition with t equal to 0. Then the solution will be psi is equal to 4 pi by AC into 1 minus e to the power t by tau t, tau e, where tau e is nothing but a 4 v by AC. 4 v by AC is the tau e. So, this is the psi energy density expression. This is energy density expression is 4 pi by AC 1 minus e to the power t by tau e. This way along the time the sound energy density will be increased. Okay. Now, what is reverberation time? You heard about the reverberation time. Let us assume that in a live room a sound source has been turned on for long enough period to establish the steady state density. Let steady state density is psi 0. I have let this room, I switch on the loudspeaker and allow to on the loudspeaker, I switch on the loudspeaker to a such a long, let's for time for particular some time, so that the steady state energy is developed in this room and which is psi 0. Now, at t equal to 0, I switch off the source. What will happen? Sound energy is developed by multiple reflection. Now, at t equal to 0, I switch off the source. Then, this psi 0, the energy density in this room is not 0 within that time. Then and there, this energy density cannot be 0, because the sound which is started from here, it will be reflected from the wall and come back. So, it has required some time to psi 0 becomes to 0. Psi 0 becomes to 0, requires some time. So, reverberation time is defined, reverberation time or RT60 is defined the time for the sound energy to drop by 60 dB. So, at t equal to 0, room has a sound energy density psi 0. To drop that psi 0 to 60 dB, the required time is called reverberation time. Am I explained clearly? Suppose I switch on a loudspeaker in here for a certain time, then let us that at steady state energy density on this room is psi 0 is developed. Now, I switch off the loudspeaker. Then and there it cannot be 0. So, it requires some time to drop the sound level to 0. Now, reverberation time is defined as, if I switch off the sound loudspeaker from t equal to 0 to that t, by the time the energy density of this room is dropped to 60 dB. So, if it is psi 0, then it is dropped to 60 dB. Okay. So, RT60, so what is psi? Is nothing but a 4 pi by AC minus e to the power t by tau e. So, at t equal to 0, what is psi? Is 4 pi by AC. This is the discharge equation. This is like a capacitor. If you charge a capacitor, then you switch off the power, switch off the volt, remove the supply. Is the capacitor then and there discharge? It requires some time to discharge. That is the discharge equation. In that rate, the energy will be discharged. So, that discharge equation, I said that this is discharge like this way. I said this is time. I said that if the discharge level is this, then this time is called reverberation time. Then I can calculate this time by discharging that t. So, at t equal to 0, psi is nothing but a 4 pi by AC. When the sound is steady state, so energy density on the room is 4 pi by AC at t equal to 0, e to the power 0. Four pi by AC. Okay. So, in that case, it is 4 pi by AC or what? 4 pi by AC. So, now I said the time psi 0 has to be dropped by 60 dB. Okay, 60 dB drop. So, if it is psi 0 is let us x, then I have to x dot is the next energy which is dropped by 60 dB. So, I can relate that equation and calculate RT 60, that I put the T equal to RT 60. So, RT 60 I put in here T equal to RT 60, then I calculate the time and I can find out. So, RT 60 will be 13.82 tau e. So, psi equal to psi 0 is into e to the power t minus t. Okay. That is this way it will be discharged. What is there? Discharge equation is that once the source is off, then psi will be discharged psi 0 into e to the power minus t by tau e. Okay. Now, I said the time taken to drop it 60 dB, time taken to drop it 60 dB. So, psi 0 in dB, let us reference dB is r. So, psi 0 in 10 log psi 0 by psi r, let us reference is r, is 60, this is, and then 10 log, let us it drop to 60 dB. So, I can calculate that things and equate with that at t equal to RT 60. Let us, it is psi is nothing but a psi r, capital R. So, psi r and psi difference is 60 dB. Psi minus psi r is nothing but a 60 dB. So, if it is that, then I can calculate RT 60 is nothing but a 13.82 tau e. If it is 13.82 tau e, what is tau e? Tau e is nothing but a 4 V by AC, 4 V by AC. So, it is nothing but a 13.82 4 V by AC. I will show you that in next slide how it is come 4 V by AC. Okay. Now, if it is C is in let C is equal to 343 meter per second and A is in matrix 7, that means in matrix system, then C I put the value of C here and I get RT 60 is nothing but a 0.161 V by A. V is the volume of the room and A is the absorptivity of the room in 7. So, suppose I told you to calculate the reverberation time of an auditorium. So, if I know A and if I know the volume of the auditorium, I can say RT 60 is nothing but a 0.161 V by A. Or if I know the RT 60, then observation time or volume, then I can say the what absorptivity I required. So, somebody told you design a auditorium whose reverberation time will be let us 1.2 second. So, I put RT 60 is 1.2 second, I know the volume of the auditorium from the civil specification and then I know what should be the total absorptivity A in 7. Now, I know the surface area, I treated with a different material to reach that absorptivity. Once I reach that absorptivity, my reverberation time will be 1.2 second. So, that way we will design that things. If it is feet, then it is 0.49 V by A, 0.49 V by A. Okay. Now, once I know the RT 60, if you see, I said from any point there will be different number of reflection will be there, summation of the reflection. So, can I calculate that mean free path, that what should be the mean path of all the reflection? What is the expression for a mean free path of all the reflection? Okay. Let us, it will be done in the next class. Okay. Thank you.